All right, today we're talking about end-tidal CO2 and a couple common misunderstandings that we see surrounding it. One of them is calibration. We'll get to that in a minute. The second one is oxygen delivery and how it affects our end-tidal CO2 reading. So we're going to talk about a couple things. One of them is the anatomy of the device itself. When we're flowing oxygen through the nasal cannula, it's not actually coming through these nasal prongs. The nasal prongs are just there to receive end-tidal CO2. Same thing with this little device down here. All this is doing is catching end-tidal CO2. All these are doing is catching end-tidal CO2. When we're flowing oxygen, it's actually coming through these little holes right up top, and it's kind of misting their upper lip. It's also coming through these little guys in the middle and kind of hitting them right in the top of the lip. It creates a nice little cloud of oxygen around them. It is effective, but it's not quite as direct as a traditional nasal cannula. So let's talk about some of the limitations of this and when we see it run into problems. One of them is just flow rate. So if you look on the packaging, it'll actually tell you got to have less than or equal to 5 liters per minute for this to get an accurate reading. More than that is going to wash away the end-tidal CO2 that would have been picked up by these sensors here. So if we start blasting oxygen through here, it's going to displace some of that end-tidal CO2 that we would have been able to pick up. All right, so our regulators go from 4 to 6 liters. So our limit practically is going to be 4 liters per minute. There's one more notch up and we're going to be over this limit. And we're going to start having an affected end-tidal reading. Now, I tested this with oxygen. I didn't see an appreciable difference at 6 liters. Maybe 1 or 2 millimeters of mercury, not a whole lot, but just know that it is possible. I also tested this device underneath CPAP. Now with CPAP flowing, I started at 5 centimeters of PEEP, and I saw maybe a 1 to 2 millimeter drop in average end-tidal CO2 reading. As I increased that from 5 to 7.5 to 10 centimeters, I saw up to maybe a 5 millimeter drop in end-tidal CO2 reading. So you can use this underneath CPAP, but know that you're going to get a relatively significant drop in your end-tidal reading, and know to kind of expect that. Reassessment after CPAP is going to hinge more on our physical assessment. Okay, so what do they sound like? Are they reporting relief? Things like that. You can use end-tidal. The shape of the waveform is still very important for us, but know that the numerical value is going to be affected by the high flow that CPAP device is kicking out.
Do you have to let this zero out in room air before applying it to a patient in order to get an accurate reading? No, you do not. If you don't believe me, we're going to test it, all right? So, first, let's do it the old way. Let the pump kick on. This is sitting out in room air. We'll wait for a 0 and then apply it. All right, we'll see what we get. We're getting a reading of 37. Breath rate of 15, right across the board. Now, I'm going to put the cannula on first and breathe. All right. Plug this guy in while the cannula is applied. Then hit CO2. It's going to initialize while I'm breathing into this cannula. $32. And we're right back where we started. 36, breath rate of 14. You can assemble this setup in any order. You can apply it to the patient, then plug it in, then hit CO2. You can plug it in, hit CO2, wait for it to 0, then apply it to the patient. You'll get the same reading regardless. This is true for the mainline detector as well, the barrel.